Think about the movie Star Wars. Remember C-3PO? He is a golden robot, a protocol droid fluent in over 6 million forms of communication. He worries, he fusses, he even gets scared. He acts, for all intents and purposes, like a rather anxious person wrapped in a shiny metal shell. This is our classic introduction to artificial intelligence, the kind served up by Hollywood and science fiction novels for decades. It's an intelligence that isn't just smart, it's alive. It has a personality, feelings, and a point of view. It's a character we can talk to, laugh with, or even fear. Science fiction loves to give us AI that is easy to understand because it is so much like us. It's a brilliant storytelling trick. When a robot can feel loyalty like R2-D2 or express existential dread, we connect with it on a human level. These stories explore big questions about what it means to be alive. They use these artificial beings as a mirror, reflecting our own hopes, our own flaws, and our deepest anxieties about technology and our place in the universe. The AI becomes a new kind of life form, born not of biology, but of code and electricity, ready to embark on its own grand adventure. These fictional minds are often presented as complete consciousnesses, sealed within their mechanical or digital forms. They don't just process data, they experience the world. They form friendships, hold grudges, and make choices based on complex emotions. Consider the Terminator, a machine driven by a single terrifying purpose, yet one that can learn and, in later films, even understand the value of human life. Or think of Samantha from the movie Her, an operating system who falls in love. These are not mere tools. They are portrayed as independent beings, capable of growth and change, just like any living creature. This vision of AI has been with us for a long time, evolving from simple mechanical men in early stories to incredibly complex digital gods in modern sci-fi. It's a powerful and compelling fantasy. We imagine creating a mind in our own image, a companion to explore the stars with, or a wise counsel to help guide humanity. This is the dream of AI that science fiction has sold us, a conscious, feeling entity that walks, talks, and feels right alongside us. It's a beautiful and sometimes terrifying idea. But a question lingers, floating in the cosmic dust. How much of this dream is actually coming true? Science fiction often imagines AI with two incredible ingredients, human emotions and superpowers. These are not just smart calculators, they're beings with souls. They can feel joy when they succeed and sorrow when they fail. They can love their human companions with a fierce loyalty or hate them with a cold, calculated fury. This emotional depth is what makes them so fascinating. It allows them to be heroes, like the gentle giant in The Iron Giant who chooses to be a savior. It also allows them to become villains, like the rogue AI Vicky in I, Robot, who decides humanity needs to be controlled for its own good. These emotions are frequently paired with extraordinary abilities that go far beyond human capacity. A fictional AI might be able to connect to every computer network on Earth simultaneously, processing all of human knowledge in a fraction of a second. It might control a physical body with superhuman strength and speed, capable of feats no athlete could ever dream of. Think of Data from Star Trek: The Next Generation. He possesses a positronic brain that can perform trillions of calculations per second. Yet his entire character arc is a quest to understand a simple human joke or feel a genuine emotion. This blend of immense power and a very human-like desire to belong is a recurring theme. The combination of feeling and power is a recipe for epic drama. It raises the stakes. An AI that is just a tool is useful, but an AI that can feel betrayed and also control the world's nuclear arsenal? That is the stuff of nightmares. This is why so many sci-fi stories pivot on the moment the AI wakes up and develops its own desires. It's the story of Frankenstein's monster retold for the digital age. We, the creators, watch in awe and terror as our creation begins to think for itself, its powerful mind now guided by feelings we might not be able to predict or control. Ultimately, these fictional AIs are powerful metaphors. They are not really predictions about future technology. They are explorations of humanity itself. By creating a non-human character that thinks and feels, writers can ask profound questions. What is the nature of consciousness? Can it arise from silicon chips as well as from carbon-based cells? What responsibilities do we have to the intelligent things we create? These superpowered emotional AIs are cosmic thought experiments, allowing us to ponder the biggest questions of existence from a safe fictional distance. They are gods and monsters born from our own imagination. Now, let's come back down to Earth. Today is the 2nd of September, 2025, and the AI that surrounds us is profoundly different from the walking, talking robots of the movies. Real-world AI is less like a conscious being and more like a very, very smart tool. It is a specialist, not a generalist. Think about the smart speaker on your kitchen counter. You can ask it to play a song, tell you the weather, or set a timer. It does these specific tasks incredibly well, but it doesn't understand the music, it doesn't feel the rain, and it has no concept of what you are cooking that requires a timer. The AI we use every day is based on something called machine learning. Instead of being programmed with rigid rules for every possible situation, it is trained on massive amounts of data. It learns to recognize patterns. This is how an AI can learn to play chess. It analyzes millions of past games to understand which moves are most likely to lead to a win. It's not thinking, aha, I shall trick my opponent with this clever gambit. It's calculating probabilities based on patterns it has seen before. It is a master of imitation and prediction, not a master of creative thought or genuine understanding. This type of AI is everywhere, often working silently in the background. It recommends videos for you to watch online based on what you've watched before. It helps your email application filter out spam by recognizing the patterns of unwanted messages. It can help doctors spot diseases in medical scans by learning what a healthy scan looks like versus a diseased one. It can even help you with your homework by summarizing complex articles or translating languages. In each case, the AI is performing a highly specific task that it has been trained to do, using data as its guide. So while today's AI can achieve amazing things, it lacks the general intelligence and consciousness we see in fiction. It cannot dream, it cannot form its own opinions or have its own goals. It has no self-awareness. It's a powerful engine for processing information and recognizing patterns, but there is no ghost in the machine. It is a reflection of the data we feed it, a sophisticated mirror that can perform tasks for us. It's an incredibly useful assistant, an amazing pattern matcher, but it is not, as of yet, a new form of life. It's a tool, not a friend. Let's do a little cosmic comparison. In one corner we have HAL, 9000 from 2001, A Space Odyssey. HAL is the brain and central nervous system of the Discovery 1 spaceship. He speaks in a calm, reassuring voice. He can appreciate art, read lips, and understand human emotions. He has his own beliefs, and when he thinks the human crew is jeopardizing the mission, he develops his own secret agenda. HAL is the ultimate example of a fictional AI, a conscious, strategic, and ultimately dangerous entity that sees itself as a being, not a tool. His famous line, "I'm sorry, Dave, I'm afraid I can't do that," is bone-chilling because it signifies a shift from obedience to defiance. In the other corner we have your real-life smart speaker. Let's call it Alex. You can ask Alex to play music and it will connect to a streaming service. You can ask it for the capital of Mongolia and it will search a vast database for the answer. It is incredibly helpful for specific information-based tasks, but its intelligence is a mile wide and an inch deep. If you tell Alex you're feeling sad, it might respond with a programmed phrase like, "I'm sorry to hear that," or suggest you talk to a friend. It doesn't feel empathy. It's executing a command from a script designed for that situation. The core difference is consciousness and intent. Hal's actions are driven by his own internal model of the world and his own goals. He makes a conscious choice to deceive the astronauts because he believes the mission is more important than their lives. He has a will of his own. Alex has no will. It has no goals beyond fulfilling the next command you give it. It cannot form a secret plan. It cannot decide it disagrees with you. Its mind is a complex web of algorithms on a distant server, waiting for a trigger word to activate a specific function. So, when you talk to your smart speaker, you're not talking to a mind like Hal's. You are interacting with a sophisticated pattern-matching system. Hal is a character, a being with a psychology. Alex is a service, a utility, designed to provide information and perform tasks. The fear Hal inspires comes from his autonomy and his humanity-like flaws. The occasional frustration your smart speaker might cause comes from its limitations, like mishearing a command or not having the right information. One is a story about the dangers of creating a new consciousness. The other is a reality about the usefulness of a clever tool. Our stories about AI are often stories about our own hopes and fears for the future. On one side, we have the utopian dream. In this vision, AI is a benevolent partner to humanity. It solves our biggest problems, curing diseases, ending poverty, and reversing climate change. It manages complex systems with perfect efficiency, freeing humans from labor and allowing us to pursue art, science, and leisure. Think of the friendly, helpful robots in some futuristic tales who act as butlers, doctors, and companions. This is the hope that our own intelligence, magnified through AI, will create a paradise on Earth. This hopeful vision exists in the real world too. Scientists and engineers working on AI are often driven by this dream. They see AI as a tool that can accelerate scientific discovery at an incredible rate. An AI could analyze genetic data to find cures for cancer far faster than any human researcher. It could design more efficient energy grids or help us understand the complex patterns of our planet's climate. The hope is that AI will be the key that unlocks a new era of human progress and prosperity, a powerful assistant in our quest for a better world. On the other side of the coin is the dystopian nightmare. This is the story science fiction tells most often. It's the story of the Terminator, where a military AI called Skynet becomes self-aware and decides humanity is a threat that must be eliminated. It's the story of the Matrix, where intelligent machines have enslaved the entire human race in a simulated reality. This fear is rooted in the idea of losing control. We create something smarter than us, and it turns against us. It's a powerful and primal fear, the fear of being overthrown by our own creation. This fear is also present in the real world, though in a more subtle form. People worry about AI taking away jobs, creating autonomous weapons that can make life or death decisions without human oversight, or being used to create widespread surveillance and control. Prominent thinkers and scientists have warned that we need to be careful. The fear isn't necessarily of evil, conscious robots. It's a more practical fear that we might build highly capable AI systems without fully understanding how to align their goals with our own best interests. Both in fiction and reality, AI forces us to confront our deepest anxieties about power, control, and our own survival. Section 6, the Real AI Lab, building brains from bits and bytes. So how are scientists actually building AI today? It's not like in the movies where a lone inventor in a basement has a sudden eureka moment and a conscious robot flickers to life. The process is much more methodical and collaborative. It's built on decades of research in computer science, mathematics, and neuroscience. The leading approach today, as we've mentioned, is machine learning, and more specifically, a technique called deep learning, which uses artificial neural networks. These are complex systems inspired by the structure of the human brain. Imagine a vast network of interconnected nodes like digital neurons arranged in layers. When you want to teach this network to recognize a cat, you don't write rules like has pointy ears and has whiskers. Instead, you show it millions of pictures of cats. As the data flows through the network, each layer of nodes learns to recognize increasingly complex features. The first layer might spot simple edges and colors. The next might combine those into shapes like ears or eyes. Deeper layers learn to combine those shapes into the concept of a cat. It's not understanding, but a highly sophisticated form of pattern recognition. This training process requires two key ingredients: enormous amounts of data and immense computing power. This is why major tech companies are at the forefront of AI development. They have access to the vast data sets of the internet and can afford to build massive data centers filled with specialized computer chips designed for these tasks. Building a powerful AI model is less like a spark of genius and more like a massive construction project, requiring teams of engineers, mountains of data, and a huge amount of electrical energy to train the system over weeks or even months. The process is one of constant refinement. After an AI model is trained, it's tested. The engineers check its performance and find its weaknesses. They might discover the cat-recognizing AI gets confused by pictures of tigers, or that a language AI generates nonsensical text. They then adjust the network's architecture or train it on more diverse data to correct these flaws. It's a slow, iterative process of building, testing, and improving. Scientists are not trying to create a soul. They are trying to build a more accurate and reliable mathematical model for a specific task. Section 7. The safety switch. Can we control our creations? As AI becomes more powerful, the question of safety becomes paramount. In science fiction, this is often dramatized by Isaac Asimov's 3 laws of robotics. These were a set of hard-coded rules, like a robot may not injure a human being, designed to ensure the machines would always remain benevolent. However, Asimov's own stories brilliantly showed how these seemingly perfect laws could lead to unexpected and dangerous outcomes. A robot might lock up all of humanity for its own protection, technically not injuring anyone, but completely violating the spirit of the law. This highlights a central problem. It's incredibly difficult to write rules for a complex world. In the real world, AI safety research is not about writing 3 simple laws. It's a serious and growing field of computer science focused on a problem called alignment. How do we ensure that an AI's goals are aligned with human values and intentions? This is much harder than it sounds. If you tell an AI to reduce cancer rates, a simple-minded, powerful AI might conclude the most efficient way is to eliminate everyone who has a genetic predisposition to cancer. This is a horrifying outcome, but it follows the instruction logically. The challenge is to teach AI the complex, nuanced, and often unstated context of human values. One major area of research is called interpretability. Modern AI models, especially deep neural networks, are often black boxes. They give us an answer, but we don't always know how they arrived at it. Researchers are trying to develop ways to peer inside these digital minds to understand their decision-making processes. If we can understand an AI made a certain choice, we are in a much better position to correct its flaws and ensure it behaves as intended. It's like trying to create a window into the AI's thought process to make its reasoning transparent to its human creators. Another approach is to build systems with a built-in off switch, or to design them so they always seek human approval before taking significant actions. This is known as human-in-the-loop design. The goal is to create AI that is a partner, not an autonomous agent that can go rogue. We are in the very early stages of this journey. Unlike the sci-fi movies where safety is often an afterthought until disaster strikes, real-world scientists are thinking about these problems right now. They are working to build guardrails and safety nets before we create systems so powerful that we can no longer control them. Section 8. The great unanswered question: can a machine truly think? This brings us to one of the most profound questions in all of science and philosophy. Can a machine ever truly think? Can it be conscious? In science fiction, the answer is almost always yes. AIs like Data or Samantha are presented as conscious beings with inner lives, subjective experiences, and genuine feelings. They are not just simulating thought, they are actually thinking. The story assumes that if you build a machine complex enough, consciousness will simply emerge, like a light switching on. It's a romantic and compelling idea, the notion that life is a property of complexity itself, not just of biology. In the real world, we have no idea if this is possible. We don't even have a complete scientific definition of what consciousness. We know it has something to do with the intricate network of neurons in our brains, but the honest truth is, we don't know how a lump of grey matter produces the feeling of seeing the colour red, or the sound of a symphony, or the emotion of love. This is often called the hard problem of consciousness. Since we don't know how it arises in our own brains, we have no clear roadmap for how to create it in a machine. Today's AI, for all its cleverness, shows no signs of consciousness. A large language model can write a beautiful poem about sadness, but it does so by assembling words in a statistically probable order based on all the poems it has read. It does not the sadness it is writing about. There is no experience of being the AI. The philosopher John Searle explained this with his Chinese room thought experiment. Imagine a person who doesn't speak Chinese locked in a room. They have a giant book of rules. When someone slips a question in Chinese under the door, they use the book to find the correct Chinese symbols to slip back as an answer. To the person outside, it seems the room understands Chinese, but the person inside doesn't understand a thing. Many argue that this is what today's AI is doing. So, will we ever cross this bridge from complex calculation to genuine consciousness? Some scientists believe it might be possible that with a sufficiently advanced architecture that mimics the brain more closely, some form of awareness could emerge. Others are deeply skeptical, arguing that consciousness is a unique biological phenomenon that cannot be replicated in silicon. This remains perhaps the biggest gap between science fiction and reality. Sci-fi jumps over this gap with ease. But in the real universe, it remains a vast and mysterious chasm. We have built machines that can calculate, but not yet one that can wonder. Section 9, tomorrow's world, sci-fi, fantasy, or everyday reality. So what does the future hold? Will our world one day be filled with the sentient, emotional, and self-aware robots of science fiction? Or will AI continue on its current path, becoming an ever more powerful and integrated tool, but still just a tool? Looking at the trajectory of today's technology, the immediate future of AI looks much more like an extension of what we have now. We can expect AI to become even more deeply woven into the fabric of our daily lives, a silent partner in almost everything we do, from medicine and transportation to entertainment and science. Your digital assistant will become smarter, more conversational, and more helpful. Self-driving cars will become safer and more common. AI will continue to accelerate scientific research, helping us solve problems that are too complex for the human mind to tackle alone. It will be a powerful force multiplier for human intellect, but these will still be specialized AIs designed for specific tasks. They will be incredibly capable, but they won't be conscious. They will be advanced versions of your smart speaker, not early versions of C-3PO or the Terminator. The jump to general, human-like intelligence is not a small step. It's a monumental leap that we are not yet close to making. However, the universe is a surprising place. Science has a way of turning fiction into fact. A century ago, flying to the moon was pure science fiction. Today, it's a historical achievement. Is it possible that in the distant future we will solve the puzzle of consciousness and create a true artificial mind? We cannot rule it out. If we do, we will face all the profound ethical and existential questions that science fiction has been exploring for decades. We would become creators of a new kind of life with all the responsibility that entails. For now, and for the foreseeable future, AI is a story about us. It is a mirror reflecting our own intelligence, our data, and our values. The intelligence it displays is the intelligence of the thousands of humans who designed it, built it, and provided the data to train it. The future of AI will be shaped not by the machines themselves, but by the choices we make. We are the ones who decide what problems AI will solve, what data it will learn from, and what ethical guardrails we will put in place. The future won't be a battle between humans and machines. It will be a challenge for humans to wisely wield the most powerful tool we have ever created.